All right, everyone. This is Sahib Bashir. I am a faculty member at Department of Commerce, University of Gujarat, and I am a PhD scholar at Halle College of Commerce, University of Punjab, Lahore. So today is basically the 22nd day for our training session on Stata, and we have covered a lot of topics which I have indicated in yellow font like basic environment, data management, graphical visualization, descriptive, mean comparison, correlation, association, regression, assumption of regression, remedies in case of violation of assumptions. But there are certain topics that we need to deal with, like regression with categorical dependent variable, that I am going to start today. It includes logistic regression, exact logistic regression, multinomial logistic regression, ordered logistic regression and probit logistic regression. And in the next week, which would be the last week for Stata training, it includes the time series regression analysis, which includes the stationarity model for stationary data, model for non-stationary data, and advanced model like a time series ARDL model, etc. So these are some of the advanced topics that we have covered so far, like panel data regression analysis using static panel, fixed effect, random effect, pooled OLS, and panel ARDL, quantile ARDL, and MMQR, which is a novel method for method of movements quartile regression. And then we have also discussed the dynamic panel with endogeneity, sorry, and difference DMM and system DMM. So today we are going to cover our discussion on regression with categorical dependent variable with logistic regression analysis. So let us start the discussion on today's topic. So the regression with categorical dependent variable includes the logistic regression, exact logistic regression, multinomial logistic regression, ordered logistic regression, and probit logistic regression. So the first of all, you need to understand what is logistic regression and why it is used, and in what circumstances we need to use the logistic regression. So you need to understand the concept. Logistic regression, also called a logit model. Sometimes if you are confronted with a pure statistician or pure econometrician, they would call it as a logit model. So the full format is known as logistic regression, while in the short form, you would call it as a logit model. So it is used to model the dichotomous outcome variable. In the logit model, the log odds of the outcome is modeled as a linear combination of the predictor variable. And if we understand it in simple word, the logit model is a type of statistical model used for binary outcome variable. Here, the outcome variable means the dependent variable. So when you have a binary dependent variable, it means the coding of that variable is either is coded by 0 or 1, then it is called as binary outcome variable. So where the responsible response variable can take only two possible values, either 0 or 1. So it is commonly used in the fields like epidemiology, psychology, and economics to model outcomes like success or failure, yes or no, etc. So when you have two outcomes relevant to a particular scenario, you are going to model your dependent variable as a binary outcome variable. So this kind of model is considered as a logit model. In detail, I would like to show you some wording of it. Like if you see here, the word, what does it mean by log odd? I have created a comment on it for your understanding. The log odds or logarithm of odd is a transformation applied to probability of an event occurring expressed as the ratio of probability of event happening to the probability of it not happening. So this is known as log odd. I will let you know how to estimate the log odds using this procedure because it will let you know the probability or the percentage of an event happening or event occurring uh, a, as a comparison to event not occurring. So this is known as log odds. The further thing that we need to understand here is the example of logistic regression. What are the practical example? How can we understand that this type of regression is known as logistic regression? For example, if you see the example one, if you barely understand it, suppose that we are interested in a factor that influence whether a political candidate wins an election. So the outcome, the response variable is binary, win or lose. Uh, with the win, we indicated by 1 or lose, we indicated by 0. So if we want to understand whether a political candidate is going to win an election or going to lose an election, then it is a binary variable which is indicated by either 0 or 1. So the independent variable would be amount of money spent on the campaign, the amount of time spent campaigning negatively, and whether or not the candidate is an incumbent. Incumbent means the person who is already holding some office and he's a previous candidate, he's already holding some office. So that is known as incumbent. So, example two would be a researchers interested on how the variables such as GRE score, GPA, and prestige of the undergraduate institution affect admission into graduate school. The response variable would be either the student would be able to get admission or would not be able to get the admission. So these are the independent variable on the basis of which we want to know whether a student would be able to get admission in a particular institution or not. So we are going to focus on example number two for our practical analysis here. So let me use this data using the procedure. I will share this data with you. Let me share this data with you. This data is available with my folder using logistic regression example 2 and 3. So let me share both of these data set with you so that you may be able to apply the same procedure. Let me show you this data. Uh, Regression logistic, and these are the data you can use for your procedure. It means we have two options, for example, gender male or female. It may be gender male or female, but you always remember that there are chances that either yes or no may be the option would be for dependent variable. So when you have binary coding of your dependent variable, either with yes or no, success or failure, admission or no admission, then you are dealing with logistic regression. It means that your dependent variable having two options. So let me explain this procedure using logistic regression example. I have shared with you example two data set. Basically, this particular example is relevant to example number two. So let me discuss this first so that we would be able to use it. So this data set has binary response or outcome or dependent variable called admit, whether you got admission or whether you do not got admission. So there are three independent variables, GRE, GPA, and rank. we will treat the variable GRE and GPA as a continuous because the values available as a GRE and GPA would be continuous. The variable rank takes on the value of 1 through 4. It is basically institutional ranking. Uh, the institution with highest prestige is indicated by 1 and 4 with the lowest prestige. So student may be interested with highest ranking institute or whether it is considered the or he has or she has considered the lowest ranked institute as per his authority GPA, GRE scores. So these are some basic considerations that you need to meet. So let me explain the whole procedure in front of you so that you may be able to analyze your data using logistic procedure. So let me open here this data file. Let me open this data first and then we need to open the data set. So I need to go to the open and we need to open the example 2 that I have already shared with you. So you will see here there are 4 variables: admit, GRE, GPA, and rank. And if we see the structure of these variables, you can see here the admit is coded with 0 and 1, where 0 means that the student would not be able to get the admission, and 1 indicates that the student would be able to get the admission. So this is the dependent variable. So whenever your dependent variable is coded with 0 and 1, it means you are going to use the logistic regression. Now you would see that there is GRE score and there is a GPA. The GRE score and GPA both are basically the continuous variable. And if you see there is a variable which is indicated by the name rank. And we have already discussed that one means that the institution where you are going to or whether where you are planning to get admission is highest rank, and 3 means that the institution or 4 means that the institution has lowest rank. So these 3 are the independent variable where these 2 are the continuous and this one is ordinal and this one is binary variable. So first of all, we need to consider some of the basic commands to understand our data. So in order to correctly apply the logistic regression procedure, you need to start from the basic commands like sum command. So first of all, I need to write here sum. In order to create the descriptive analysis, I just need to click on these arrow signs like this. And then I need to click on enter and it will show me the basic descriptive statistics of my data. If you can see here, the minimum value in the admit is 0 and maximum value is 1. That is why it is a binary variable. It is a binary dependent variable. If you see in the GRE, the minimum value is 220 and the maximum value is 800. That is basically the normal range of graduate record examination score. And then you see the GPA. The minimum GPA is 2.26 here and the maximum is 4. And the rank, it is indicated by minimum 1 and maximum 4. And here the average values of these variables are also located. For example, in case of admission, the average value is 0.31. In case of GRE, the average score is 587.7. Average GPA is 3.39 and average rank is 2.48. So these are the normal data while the number of observations are 400. So it will give us a brief overview of our data. Then the next command is, if we see here, there is a rank variable which is ordinal. Two of our independent variable, if we see here, GRE and GPA, they are continuous variable. But we have two rank variable, two ordinal variable. The first one is rank that is basically the order from highest to lowest. And if we see here, there is admit, which is dependent variable. It is also ordinal with 0 and 1 indication. So we need to tabulate this data. For example, I need to write here tab, and I need to see the values of rank. If you see here, there are 61 candidates basically considered rank 1 data. Rank 1 means highest ranking institutes, then 151 considered the second ranking institute, third ranking institute is considered by 121 candidates, fourth ranking institute is considered by 67. So if we need to see how many people got admission in order of these ranking, what we need to do, we need to write here tab rank and then admit. Using this command, we would be able to understand how many people got admission or do not got admission as per the ranking of the institute. So you just need to write it, and you will see that 0 indicates the student could not got admission, and 1 indicates that the student got admission. So in highest ranking institute, 28 students could not get the admission, and 33 students can get the admission, or could got the admission. In this second ranking institute, 97 students could not get the admission, while 54 students got the admission. In the same way, on the third ranked institute, 93 students could not get the admission, while 28 got the admission in the third ranked institute. And in the lowest ranked institutes, 55 students could not got the admission, while 12 students got the admission. So we can say that out of 400, only 127 students got the admission in in highest to lowest ranked institutes, while 273 students could not got admission in highest to lowest ranked institutes. So this is the idea how you can use the tab rank command. Then if you see the procedure, the next is logic command, simple logic command. If I need to run the logistic regression, I need to write here logic. You just simply need to write here logic. If this command is not recognized in your Stata, you just need to write SSC install logic. But if this command works, you don't need to install it. So you need to write here logic. Then you need to put your dependent variable first, that is admit, and then you need to put your independent variable one by one. Now, these are your independent variable with the logic command, which is basically logistic regression. You can run it simply, and you will see the results. Here, the first thing that we need to see is probability greater than chi-square. Uh, it is less than 5%, so we can say that model is statistically fit. Then you need to see the shadow R square. It is indicating 8%. So our independent variable are explaining 8% to our dependent variable here. So the impact of GRE on the admission score is positive and statistically significant. The impact of GPA on admission is also positive, and it is also significant. Then the ranking of the institution, it is negatively uh, 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 negatively linked with your admission procedure here. So this is a simple logistic regression, but you need to understand that Z means p-value. 1.96 we consider. Yes, Z is basically the alternative to C. So you can consider it that if t is written here, then we can say that the value greater than 1.96 would be considered for significance. So here all the variable are significant. So the one thing that I would like to let you know is that among your independent variable, the rank variable is also ordinal. So when you are using some ordinal variable, you need to change the command. But before running that procedure, the session is going to end, and you should use the same link for joining again for this session so that we can consider another session for running the procedure and understanding how the logistic regression works here. So please join this session again using the same link that I have previously shared so that we may proceed.